All right. Variation and past tree. All right, so like I said, right, your variation can be represented by a tree, right? By a tree. So now, given this grammar, E goes to E plus E, or E times E, or parenthesis E, or ID. And the input is ID times ID plus ID. So we are trying to use this grammar to match this input. If we can match it, then that means this input is correct. Right? Satisfied is belong to part of our language. Okay. So the expression is starting from the start symbol, right? Here we only have one production rule. So start with E. So the left-hand side, we have expression is E. Okay. On the right-hand side, the tree is starting from the root. Okay, so the root is also E. Okay. So far, so good. What is expression? What's past tree? Good. All right. So let's say I am choosing E plus E. Right. It's a series of replacements, right? So I'm replacing E by E plus E. Okay. Then for my past tree, then I'm appending my children. All right. That's my children. E become E plus E. Does it make sense? Good. So far, so good. So next, I am replacing the first E by E times E. Right. So here, you can see, right, the first E is being replaced by E times E. Right. Therefore, we have E times E plus E. Are we good? Clear? All right. Then I can replace the first E by ID. All right. Second E also replaced by ID. Right. Just keep adding children, right? And the last E also is ID. All right. So realize here ID times ID, ID times ID plus ID is equivalent to the input string. All right. It matches the input string. So therefore, this input is a valid. Okay. Okay. And also look at the pass tree here. All the leaf, well, where are the leaf? This is the leaf. Leaf is the one has no children. All right. All the leaf are terminal. All right. All the leaf are terminal. All right. And all along terminal, they're not leaf. Make sense? Because once you generate, right, it's permanent, right? You don't have to derive that anymore for terminal. Okay. Are there any questions? All good? Are we clear? All right, so, but before we choose E plus E, right? But we don't have to choose E plus E. All right, this grammar also allow us to choose E times E. So instead of choosing E plus E, we can choose E times E, right? All right, nothing wrong with that. All right, that's part of the grammar, right? So we are going to do that. Okay, let's see what happened. Okay. So the same, right? Doesn't matter which one we choose, we always start from the starting symbols, right? Starting symbol, in this case is E. Therefore, E is also the root of the tree. Okay. All right, so we choose E times E, right? So this time we choose, instead of E plus E, we choose E times E. So we're appending E times E to the as a children of E. Okay. Are we good? So let's say I replace the first E by ID. Okay, first E by ID. All right, and only have one E left, right? So we only have two terminal, ID and multiplications, right? So one E left. Then I'm gonna replace the second E by E plus E. Okay, then this E is being expanded by appending the E plus E as his children. So far so good. And we have ID times E plus E. Right? So next, I can replace the second E and the third E by ID, right? ID. Okay, then we have ID times ID plus ID. Right, we also match our input string. All right, so also indicating this input is valid. Okay, so we choose E plus E and E times E. So both verify the input string ID times ID plus ID is a valid string, right? However, look at the parse tree. So this one is this one, right? This one is E times E. Let's go back to look at the this one is we choose E plus E first. Okay, are they the same or they're different? Are they the same or different? All right, look at this one before. It's E times E. Are they the same or they're different? I'm asking for the tree. A different tree, right? A different parse tree. So is it a good thing or is it a bad thing? Some people say good, some people say bad. So who thinks good? Raise your hand. No one. Who thinks bad? Raise your hand. 5. Or it's about other students. They're sleeping, right? So it's time to wake up. Okay, let me ask again. Who think this is good? Raise your hand. Nobody. 1, 2, 3, 4, 5. Raise your hand on 6, 7. All right. Who think this is bad? Raise your hand. I still don't have all the students. I still have students sleeping. All right. Let's do this one more time, right? All right. We keep doing this, right? It's a recursive structure. I keep calling back to the E, right? Until I have all the students. So who think this is good? Raise your hand. A little bit more, about 8 or 9. Who think this is bad? Raise your hand. See, you're still sleeping. I caught you this time, right? All right. So this is not a good thing. Not a good thing because we have 2. Right, because we have 2 past 3. Okay, this is ambiguous. This is ambiguous. Okay, so that what does it mean? Doesn't mean compiler need to choose. It doesn't know which one to choose. Right. So you may think computer is a smart, right? Actually, computer is just do whatever your program tells to do. Okay. So this is not a good thing for the same grammar. For the same grammar, it could produce 2 different parse tree for the same input, which is not a good thing. Okay, you want it to be unique. So what are we going to do? We need to rewrite the grammar so that it will not generate more than one parse tree, right, for the same input. Okay, so one thing you need to be very clear here. I'm asking you to rewrite the grammar. Okay, I'm not asking you to modify the grammar. Whatever you rewrite has to generate or accept the same type of language. Otherwise, all bets are off. Okay, is that clear? I'm asking you to rewrite it in a different way. Okay, just like your English, right? English, you can write some sentence, many different sentences for the same meaning. Okay, but you should not change the meaning. You got it? Okay. So here, so for this grammar, right? This is the original grammar. E goes to E plus E, E times E, parenthesis E and ID. I'm going to rewrite this one. Here is how I rewrite it. Right, the input is the same. ID times ID plus ID. Okay, so now E goes to E prime plus E or E prime. And E primes go to ID times E prime or ID or parenthesis E close parenthesis times E prime or parenthesis E and close parenthesis. Okay. So let's see why this is the case. Okay. So the input is ID times ID plus ID. So we start with E, right? E is the start symbol. So E is our starting symbol. Okay. So in here, first we must choose E prime plus E because it matches our part of our input, whereas E prime is not. Okay, so we are choosing E prime plus E. Okay, so once we choose E prime plus E, then go to E primes, right? So E prime, so plus is already there. Okay, plus is already there. So what are the options we have? Okay, so our input is starting with ID, right? Here, so you can just immediately eliminate this 2. Well, because they're starting with a left parenthesis, right? They're not going to match. Okay. Okay. So what we want is we want something to have no choice. It forces us to get this round. Okay. So before we have a choice, right? We can choose E plus E and E times E, right? So now we want to make sure we have no choice. Okay. So the other two start from premises. That's not our case. Okay. So in here, then we have ID, and ID times E primes, right? So both start from ID. If we choose ID here, okay, then it's going to be ID plus E. ID plus E, right? ID plus E. Okay, and we cannot choose any other derivation to match this input. So that route is not correct route. Do you agree? But take a look, right? What happens if I choose ID? Can you match? Can you match the input? Okay. Everyone convinced? ID is not the right choice. All right. Then leave us a no choice, right? We have no choice, then you have to choose ID times E prime, which is what we have here. So this E prime is going to be replaced by ID times E prime. Okay. So we have ID times E prime plus E. All right. Do you agree? So we have the first two is already terminal, ID and times. Okay. Then we're going back to E prime. We're going back to E prime. So what are the right choices? Only right choice is the second one, ID, right? So therefore, we expand that to ID. So ID become the children of E prime. Okay, so then we have ID times ID. Okay, plus E. Okay, so now this is being covered, right? ID times ID, they're covered already, right? ID times ID plus actually. Okay, the only thing left is the last E. So now we're going back to E. Look at E, right? We have two options, right? E prime plus E or E prime. So E prime plus E is not going to match, right? Because I have plus sign there. Okay. So let's leave our only options is going to E prime. Okay. So now we're going to E prime. So which one's going to match ID? Is the second choice, ID. So this is the ID. So ID times ID plus ID, which is match our input. Okay. Not only it match our input, but when we're making our derivations, we don't have any other choices. All right. That means it is not going to generate another path tree. This is only path tree because this is the only option we have. Is that clear? Are we good? Any questions? Clear? I'll find out pretty soon, right? We'll have an exercise for you.
Professor, can you explain it one more time, please?
One more time from where?
From E dash, like why we choose E dash over E?
Why we choose what? Say again.
Why
Can't
we
hear you.
choose? Yes, yes.
Can you say again? I cannot hear you.
I mean, why we choose E dash over E, Professor, in this case? So that part I didn't get it.
Which I still
E-
don't know which
Um,
one you're asking.
So here E gives E dash plus E, right, Professor, or E
Yes,
dash.
E
So,
go to E prime plus E or E prime.
yes, yes, Professor. So why we choose E prime plus E instead of E
Well,
prime?
because that's it. That match part of our input, and E prime is not.
Okay.
Is that clear? Anyone else? Yes. What? What are you asking? E prime times ID. So in here, right? So we already choose E prime plus E, right? Okay. So let's just erase this. Okay. So we already choose this, right? So we are in E prime. We're in E primes, right? So we know there's a plus sign here. There's a plus sign here. Okay. So now what is our input? Our input is starting from ID, right? This on the left, right? So starting from ID. So now you look at the third option and fourth option first. What is it? What is it start? It start with a left parenthesis, right? So it's immediately they're not a match, right? So those options are gone. Okay. Okay. So far so good. So it leaves only these two options, right? The first one and the second one, right? So let's consider second one first. Okay. So here, if a second one, you have a second E prime, or E primes, right? So E prime, if I choose ID, if I choose ID, then I don't have anything to match. That's not going to mismatch, right? So second one is not the right correct route. Right. So same for this, right? It's not correct route because it doesn't match. Okay. So that leaves me only choice is the first route, which is ID times E prime. That's why I choose that. Right. So far you have no choice, right? You have no other alternative. Any other questions? Are we good? Are we clear? All right, so let's take a look at this example here. Here is the grammar. Is goes to if E, then E, or if E, then E, else E, or ID. Okay. The input string is if ID, then if ID, then ID, else ID. That's our input. Okay. So let's say, right, let's go to some variations. I can, everything starts from a root, right? So E is a starting symbol, only one production rule, right? I can choose if E, then E, the first one is going to be ID. The second E, I choose if E, then E, else E, and then all the E will be replaced by ID, which match the input, right? Do you agree? It's the same as the input. If ID, then if ID, then ID, else ID. So far, so good? Are we clear? Right. Alternatively, I can also choose if E, then E, else E first. Choose a second one first, okay? Then I'm gonna replace the first E by ID and second E by the first production rule. If E, then E, then I'll replace all the E by ID, which is also match if ID, then if ID, then ID, else ID. Do you agree? Look at it, right? Look at it. Just convince yourself this is a correct match first. Are we good? Are we clear? So they match our input, right?
After first then should there be ID?
Say again.
After first then, if ID then ID,
Yeah,
or then if.
if, right, if. After first, that is if.
No, the previous one, sir. After then.
Previous one, the previous example.
No, the same example.
The same this one, previous one.
Yeah.
It's the same. If ye, then if. After then is a if.
Okay. So it is not ID, right? ID
No
should
ID.
not be there in between.
If look at the input, right? If ID, not just ID, if ID.
Okay.
Okay. So both of this variation match our input. Agree? Right? However, look at this tree, right? Look at the tree. They're different, right? Right? Two different parts tree, right? For the same input. That means this is ambiguous. Okay? Everyone agree? They are ambiguous. So what's the solutions? We'll have to rewrite the grammar. Okay? And that is your in-class exercise. Okay? So this is your grammar. This is the same input, same grammar, same input. Just rewrite it so that it will not be ambiguous. Remember what I said, right? You are rewriting the grammar. You are not modifying grammar. So whatever I accept here, it should also accept in your new grammar, new production rule. Okay. This thing is the same as a regular expression. You have to go through your head. No choice here. So just letting you know, we have some solution. Just checking them on a whiteboard. And I don't think I can show you. See, is any probably is no easy way. I'll try to move the computer a little bit. All right, so this is the student, some of the student solutions. So they do not match the input, so that's not correct.
అంటే దాంట్లో మనకి ఐడియా
All right, so we can take a look. My option here. All right, so here is my rewritten grammar. Yi is going to go to MIF or UIF first. Okay, so not gonna match in the first level, so you get to have to try them both. MIF equal to if Yi, then MIF, else MIF or ID. And UIF is goes to if Yi, then Yi, or if Yi, then MIF, else UIF. Okay, so we got to examine that, right? We got to examine that. All right, so let's say we choose MIF first, right? Because we don't know, right? MIF and UIF both nothing match. So we gotta choose MIF first. So if I choose MIF, look at the input, right? It's starting with if. So MIF has two options. So the second one, ID, certainly is not match. So I have to choose the first one, right? If Yi, then MIF, else MIF. Do you agree? Right, so far up to here, right? I don't have any choices. Okay, so then my input, so it's all match if, right? So next one's ID. So Yi is going to go back to Yi, right? So my options MIF and UIF. And ID is only in MIF. So I have no choice. I cannot choose UIF. I have to choose MIF, right? Have to choose MIF. Okay, I divide the second one, this ID. So far, so good. Okay, then continues, right? Then next one is MIF. Right, then this next one is MIF. All right, my input is ID. My input is MIF. My input is ID. Okay. My input is if, right? After then is a if. If, right? If. So if I have chosen ID, it's not going to match, right? If I choose ID, it's not going to match, right? MIF have two options, right? If I choose a second option, that's not going to match. Right? You agree? Right? So this is not the correct route. Right? Does not match. So then leaving no choice, right? And I have to choose the first route, right? This one for the MIF. Okay. And that is if ye, then MIF, else MIF, right? So in this case, then I have two else, right? Which does not match my input. Do you agree? Doesn't match my input, right? So therefore, choosing the MIF, I exhaust all the possibility, right, for MIF. But this is not the right choice. Okay, but we still have another route, right? UIF. So now UIF. Okay, so well, we already examined MIF, right? So now we get examine UIF. So UIF, I can choose if ye then ye, or if ye then MIF else UIF, right? So let's say I choose the second route first, second option first. If ye then MIF else UIF, okay? And then the first token is already match if, right? So the second one is ID. So for ye, ID is only in MIF, right? So I have to choose MIF. Okay, so I choose a second ye, replaced by MIF, and MIF will be replaced by ID. All right, so far so good, no problem. Then I have the next MIF. Next MIF, okay? So you already examined, right? So you have to follow by the if. Follow by the if, right? Follow by the if. So ID is not gonna match, right? If I choose the first option, then I have two else, right? Same problem as before. All right? So not a match. This route is not a match. Okay? So far so good. All right. Now, leave me no choice. I will choose if ye then ye, right? If ye then ye. And the first ye is ID. So only MIF is have ID. Right? Then next one, I'm going to choose ye. I'm going to choose ye. Okay. So I can choose. That's a MIF here because I don't have space. Okay. Right. Because I don't have space. So therefore, I just skip the MIF. So ye is being expanded to MIF. Okay. And then in order for it to match, I have to choose the first options, right? Right. So that will be the if ye, then MIF, right? Else MIF. Right? You agree? Then I can, and all the MIF need to be replaced by ID. Right. And this is the match. This is only way to match the input. Okay. Are we clear? Okay. All right. So it's 2 o'clock. So I think we can stop here. One thing I want to ask you to do next week. Please bring your computer to class. We will talk about your next assignment 3, right? Or be your assignment 2 is still next Sunday, but your assignment 3 is going to take you more time to do. Okay, it's also more complex. So I need to go through that for 2 weeks. Okay, so next week at least I have some time to spend with the other patch. All right, then the week after I have time to spend with you. Okay, so make sure you're good at it. Okay, so please bring your computer to class. All right, and we are going to stop here. Any questions for the online students? Very good. And I'll see you next week. Make sure you will complete your assignments, which due next Sunday.